Hi and welcome back to Shorsel's classes. Today we are going to be dealing with optimization problems, mainly the cases of more than one choice variables. Let us begin with a simple sum. Over here we need to find the extreme values, whether it exists or not. Please notice it's written if any, for the following functions. We need to check whether they are maxima or minima by the detrimental test. So let's do the first one. Now we are given this following function. In order to find the extreme values, first we need to find f1, f2 and f3. f1 is nothing but this function z differentiated with respect to x1. Let's see what the value comes. 2x1 from here and minus 3x2. Notice all the other parts of this equation does not contain x1, hence they cancel out to become 0. Next, similarly, f2 equals to minus 3x1 plus 6x2 plus 4x3 and f3 equals to 4x2 plus 12x3. Now we'll equate all these three equations with 0. That is because these are the homogeneous linear equation system in which these three equations are independent. Thus the only solution is x1 star equals to x2 star equals to x3 star equals to 0, so that z star is equals to 0. And now we'll find the Hessian determinant. Let's see how to figure that out. Notice the three equations that we have obtained. Notice the value of x1 first. In the first, the value of x1 is 2, and the second it's minus 3. But in the last one there are no terms of x1, hence it's 0. So we'll be putting in the first column as 2 minus 3 0. Similarly we'll be doing for this next two columns. In the second column it comes to minus 3 6 4. The last column 0 4 12. Look at the equations that we have obtained and you will see this value coincide with that. Now mod of h1 equals to 2, which is greater than 0. Mod of h2 equals to 3, which is also greater than 0. These are the minus that we are taking out from this main determinant. Now we find out mod h3, which is equals to 4, which is also greater than 0, and thus consequently z star equals to 0 is a minimum. Let's look at another question. Now we are given another equation. We'll proceed similarly to the previous one. We'll find f1, f2 and f3 similarly. Pause the video because I'm going to show you in a flash all the values of the three. Just like the previous question, over here also x1 star is equals to x2 star equals to x3 star, which is equals to 0, such that notice that if all these terms become 0, x is equals to 29 in this case. Similarly we will be finding Hessian using these values and we'll calculate mod of h1, h2 and h3 just like the previous question. If you want to try it out, again pause the video because I am going to be solving it in a jiffy in the next 1 or 2 seconds. Over here the Hessian will be minus 2 in the diagonals and all the rest of the elements will be 0. This can be also written as a minus 2 into an identity matrix. Now the minor that we find out is mod of h1 equals to minus 2, h2 equals to 4 greater than, which is greater than 0, and h3 which is less than 0, and thus this condition satisfy that z star is equals to 29, which is a maximum, unlike the previous question. Now we'll solve a very famous problem. We need to find the Lagrange multiplier method to find the stationary values of z. Let me make it a little brighter. Okay, let's do the first one. A is given as z equals to xy. We are given the conditions that x plus 2y equals to 2. Now for ease, let's write always like 2 minus x minus 2y equals to 0. This equation is always very important because this is what you use to form the Lagrange. Let's assume the Lagrange equation as z lambda equals to 2 minus x minus 2y equals to 0. What I forgot to mention is that the Lagrange function, let L equals to xy plus this lambda that we considered, lambda into this whole equation. As I said earlier, this is gonna be a very important equation. Now we obtain z lambda by differentiating this whole Lagrange function with respect to lambda. Similarly, we'll do it for zx and zy. Let's see what zx comes. Zx equals to y minus lambda and zy equals to x minus 2 lambda, or equating to 0. Thus, on using this 3 equation, we'll find the value of lambda star, which comes as half, and also x star is obtained as 1 and y star is obtained as half. Therefore, from these 3 equations, we'll obtain the value of z star, which comes equals to half. Notice we have z equals to xy, thus when we put the value of x and y, that is 1 into half, we obtain this specific value, and this is valid for each and every Lagrange function that we are gonna do. Let's try out another question. Over here we are given z equals to x, y plus 4, x plus y equals to 8. Similarly, we will be doing 8 minus x minus y equals to 0, and the Lagrange function is x into y plus 4 plus lambda 8 minus x minus y. Let's find z lambda, zx and zy. Okay, these are the values that we have obtained. Z lambda equals to 8 minus x minus y, which is a simple one. Zx equals to y plus 4, since x gets terminated from here, minus lambda, since the value of x over here is minus 1. Zy equals to x minus 2 lambda. From here we'll find lambda star, x star and y star. Let's see what it comes to. Thus lambda star is obtained as 6, x star is obtained as 6 and y star is obtained as 2. Now we'll put all these values in this function. Let's see what the value of z star comes. Z star over here will come as 6 into 6 plus 4, which comes to Sorry, I made a mistake. The value of y is given as 2, to which we'll add 4. Thus it's 6 into 6, which is 36. Now we are given two extra other problems similar to this, that is C and D. I'll let you try on these questions. At the end of this video, I'm going to give the answer to all these questions. Stay tuned and try it on your own. These are the answers to both of your questions. I hope your answers have tallied with mine. If not, please check the differentiation. There might be minor mistakes that might have been incurred. No problem. It comes with practice. See you again shortly in another video. So please like, subscribe and press on the notification button.